Hi, and welcome. In this video, I'm going to cover how you can create your own specialized agents and create your own applications. There's a lot of different tools out there and tutorials about how you can chat with your PDF. And I'm going to kind of extend that a little bit, and I'm going to show you how you can take that same data and marry it up with other types of sources to really kind of combine the powers of AI with your own data. And we're going to leverage a couple different tools to do that. One is we're going to leverage LangChain, which essentially is the framework we're going to use here to it sits on top of basically multiple different types of AI models, not just OpenAI, which is the main one that we are going to be using in this video. OpenAI is essentially the models beneath the covers of things like ChatGPT, so it's the same company. So the only thing you'll really need to get started on this is you definitely will need to have an API key. I'll cover how to set that up for you, but you'll definitely need to have an API key in order to run these demos. And the API key essentially is you have to essentially pay for so much usage for a month. And what I typically do is I'll put a $10 limit or whatever on my account so that I never go over that. Having said that, essentially, these are really inexpensive queries. So in the months that I've been doing these demos, I haven't spent more than $5, and I've been running a lot of different types of applications and testing. So one specific query to OpenAI may be 2 or 3 pennies at most. A lot of times they're fractions of a penny, so it's not very expensive. But you will have to have that account, and you will have to have an OpenAI API key to get started. Okay, so that's kind of how we're gonna hook up to OpenAI. And then finally, we're going to cover and use something called Pinecone, which is a vector database. And essentially, if you're not familiar with what a vector database is and how it's used, check out my other video where I cover how you do this in order to kind of essentially take your data and put it in a format that can be read in by or understood by the OpenAI and other AI models, so that you can take larger offerings, larger documents, and be able to utilize that data. So one of the things with things like OpenAI, and you may have seen this even in ChatGPT, there's a limitation to how much data you can send. So the way around that is by creating your own specialized vector databases. So I have other videos that kind of walk through how that works. Feel free to look at that, and I'll post a link for that also in the description for this video. So those are the 3 things we're going to be using. And then for as far as Pinecone, this is free. I'm just using the free version. Essentially allows you to create one vector store, and then you have to just kind of reuse it. So other than that, it's essentially the same. But if you pay, you can obviously create as many of these as you want. But for our purposes, I'm just going to reuse this LangChain demo database for demonstration purposes. Okay. Lastly, I'm going to be using this document here. I downloaded this from the web. It essentially is a user's guide for a Vizio series of TVs. It has a lot of different information here, and we'll kind of show you how you can query this document to ask it questions, and we'll use that as part of the demonstrations for this video. All right, with that, let's go ahead and get started. So I have a Colab notebook set up here. So essentially what you're going to want to do is, to get started, is you're going to want to install a couple different tools. So you're going to install Cohere and some of these other things that are necessary to be able to read our data. So a lot of this is tools for just being able to access the OpenAI API. If you want to access the Pinecone data sets and the Pinecone client, these are what you need to install. Tick token is also required for us to be able to create our vector store. And then finally, these are necessary to be able to read unstructured data such as PDFs, which is what we'll be doing here. I went ahead and installed that already, so that's all started. So it takes care of doing that. Now what I'm gonna do is go ahead and download a sample document. So I already have that as well. This is the TV manual that I just showed you. So that's this manual here. So I essentially have that downloaded in a data folder. And what we're going to do here is read in that data. So this again is part of the whole vector store. So again, if you haven't watched my video on that, that's where you'll learn more about how this is working. But essentially, what we do here is we read in this PDF, convert it into text and then split it up and store it in our vector database. So I have one document. That's kind of essentially what this is saying here with the number 1. So I have one document here, and we split it up into chunks, and that allows us to get around the limitations of tokens within our OpenAI models. So remember, there's a limitation there. So we split it up into chunks, and we end up this allows us to essentially pull out just the pieces of the document that we care about, and we can send them to the OpenAI model as we need to. So that's essentially what happens. So we're splitting up that document into little smaller pieces. So that entire specification document was split up into 164 pieces. Again, I'm not going to cover a lot of that because that's part of another video. And here essentially is where I create that vector store. So I'm essentially creating that database and storing all of the metadata for that TV manual in that Pinecone database. Okay, you will need an API key, so you'll have to put your API key here. Then you're setting up the instructions here to go ahead and create that index. Think of this as just a database. A couple things I'll point out with this is that there are different metrics that you can read about. There's a link here that talks about that. Essentially, this is how you can use these different algorithms, if you will, to figure out how to pull out similar data. The way that this vector store works is by doing something called similarity searches. So essentially we ask it a question, and what happens is we get back the chunks of the document that potentially answer that question. Okay, that's kind of how the vector store works. So these metrics and these dimensions are all kind of related to pulling out just the pieces of the document that we care about that match the specific question that we're asking. Okay, so that's what that's doing. We're go ahead and create that. I've already done that as well. And then I'm going to be using OpenAI, so we need to have an API key. So you'll specify your API key here, and then we're going to create our embeddings. So this essentially is the actual loading of the data. So we're taking that document that we chunked into pieces. We then created the Pinecone database. We then are going to use the OpenAI embeddings model, text embeddings 80002, which is the current one as of recording of this video. And I'm going to essentially take that and store all of that data into our Pinecone database. That's what this from documents is doing. All right, now that we have that data in our database, and we can actually go look at that and kind of see what that looks like. So here is our LangChain demo database. Here are all my vectors, and vectors are just numbers that represent the similarity. They represent how similar something happens to be to uniquely identify it. Okay, so here's our chunks of data. So here, this particular first one here is that text as you see it. That's where it came from, the metadata for it, and these are the values that are used. All of this has to do with determining which chunks of that document match the question we happen to be asking it. All right, so that's all that is. It's just a number of numbers and the metadata and the actual text that goes with it in a database. Okay, now that we have that, we can then run queries against it. So if I come down here and ask a question, for example, the remote control is not responding, and I'm running what is called a similarity search against that index. Again, this is a Pinecone specific function, and I'm telling it to go look in the database, in that Pinecone database, pick out the document chunks that may answer that question based on what I'm asking. So it's looking for similar chunks of the document that look similar to the question in my query. In this case, the remote control is not responding. So it's going to pull back the documents and rank them. So that's what this is. Okay, I'm essentially pulling back those specific documents of pieces of that document. All right, and if you read through here somewhere, you can see it talks about scanning, and it talks about, I'm sure we'll see remote controls in here and batteries, replacing batteries and other things. So this is what we send to the AI model, right? So again, we get around that limitation of token size that limits how much we can send, and we're only, instead of sending that entire PDF, we send back just these 3 chunks. The K number here represents the number of chunks or relevant chunks that you want to send back. These are things you'll have to play with to figure out what makes the most sense for you. Right now, I'm only returning back 3. If I wanted to, I can do 5 instead, and you can kind of see if I rerun this query, I get a little bit more. right? So I'm sending more data. Again, being cognizant of the fact that at some point I may hit that limit of token size, right? So you got to play around with these numbers. Again, all of that is kind of talked about in my other video. All right, now that I have my database, my vector database stood up, I have my data in there, I can make queries against it, right? And ask questions like, what's remote control, why my remote controller isn't responding, how do I fix that? I can ask these questions, and now what I can do is I can initialize what is called a conversational agent, all right? And this again is going to be part of LangChain, that we're going to be using the chat OpenAI model and the conversation memory so that we have context of what we're sending it. And then we're going to be using the Retrieval QA. So we're essentially going to be asking questions and getting back answers. That's what the Retrieval QA chain is all about. There's many other types of chains that LangChain supports, and you can get to all that through the documentation as well. And I'll also be providing additional videos to cover the different types of chains. But essentially, this is a way of just asking a question and getting back a response. All right, so when I run this, you're going to be using the large language model. So here's my chat OpenAI. I'm going to be using the chat 3.5 turbo model, and I set the temperature to 0. So essentially I don't want it to be creative. That number, the temperature, talks about the creativity of the answer. The higher the number, closer to 1, the more creative it will be. But I'm really looking for exact matches here, right? So that's why I'm setting that very low. I really want to get this to be a point where I get back the response that I expect. I don't want it to randomly choose something that may be wrong. All right, and we're setting up the memory here so that we can, as we make these requests in this QA chain, that we're going to be maintaining the history of the questions, similar to ChatGPT. So as you type in questions inside of a ChatGPT session, it kind of remembers your conversation. That's what the conversational memory is. This is just the way you do that through the API. And again, you can specify how much of that memory you want to retain and so forth. All right, so now that I've got that, I'm going to set up the chain, and I'm using the chain type of stuff, which essentially says take all of this data, right? All of the data, whatever you return is from your similarity search, and stuff it into the request and send it all along with your question. So the model is going to get all of my data of the similar chunks of my document that potentially match my question that I'm asking, and then it's going to go use the AI model to figure out what the answer should be. So now that I have that, if I do a QA run and I ask the question, then I get back just a very nice message telling me exactly how to fix that. That's using the AI model to come up with that nice response back. All right, I can ask it other types of questions, like for example, what is the viewing area of the V45 3M-K04, right, TV? And again, that's context that you can get right from the document. So it's reading this document and it's able to figure out what I'm asking it. So it says the viewing area of that is 43 inches. So if I go back and look at if I go back here and look here and I scroll down, and sure enough, that is the viewable area is 42.5 or 43. So it picked out that number. I can ask it other types of questions, such as what is the power consumption of the 85M-K01 TV? And if I go back here and look, you'll see that that is this one here. And if I scroll down, here is the power consumption that goes with that. So it's pretty good. I mean, it definitely, these are things that you really need to tweak and learn how to get it to work correctly for your type of data. There isn't kind of a silver bullet where it works for everything. You really need to understand your data, how it's segmented, and make sure that the model you've chosen and the metrics you've chosen, other things, all those other factors are correct, so you get reasonable answers. But it looks like for our case, we're actually getting pretty good data. Okay. Now, if I run this query here, what is the current temperature in Washington, D.C., you'll notice that it says, I'm sorry, I don't have access to real-time weather information. Why is it doing that? Well, the reason it's doing that is because at this point, it doesn't know anything except whatever's in that TV manual PDF that I gave it. So it has no other context. It can't answer any other questions. We essentially have our own isolated querying tool for just our data. But a lot of times we want to go further. We want to be able to query other types of things at the same time, right? So in order to do that, we can load what are called tools. And tools are another of the LangChain capabilities, and they allow us to essentially put wrappers around other types of sources. For example, I can hook into Wikipedia, or I can hook into Google search, and I can let the LangChain model figure out what tool makes the most sense based on the question I'm asking. Okay, so the way you use these tools is, first off, they are wrappers around other types of functionality. So I need to install, if I want to use the Wikipedia tool, I need to make sure I install Wikipedia. If I want to use the search tool, which I'll show you both of these here shortly, I need to install that tool as well. So you have to install the foundation, because all of these LangChain tools do is they sit on top of these other foundational libraries, if you will. All right. So now that I have then pip installed, I can now run queries against it. So I can run, for example, for doing a search, I can use the SERP API. And again, that's another one of the tools. You will have to have an API key that's free as well. I will post a link for that one as well in the description, so you have access to know how to set that up. But now I can ask it questions, like, for example, what is Obama's first name? And it was able to figure out that I meant Barack Obama. Okay, so it's able to now use that tool. So now I've got my data that sits in my PDF. I've got a way to access that data. I now have the ability to also pull in data from other tools. And the other thing I can do is now want to bring these together, okay? Because they're still not the same. For example, there's no memory or anything yet for this, right? For example, if I ask it this question here, when was he born? Just after asking this question here, Obama's first name, you'll notice that he doesn't know that answer. The AI doesn't know that because there's no memory, right? There's no conversational memory yet. So we need to, what we need to do is take this tool and combine it with the other tools and our memory that goes with our LangChain memory, and bring it all together and pull these into a kind of like a collection, okay? All right, so here's another tool here. That's the OpenAI for doing weather, so I can run that. So I've got all these individual tools that I'm kind of loading in here. And then what you do is take everything together and create an agent out of it. So here I'm saying take the SERP API tool, the LLM math tool if I want to do simple math, take Wikipedia, and kind of create a collection of those tools and put them all together into, think of it as like a toolbox, right? These are my toolbox of different things that the agent can use to answer whatever questions I'm going to ask it. So these are the three tools that I just added. And then what I can do is I can take my specific vector database for my TV manual, and I can add that as another tool. So now this is the fourth tool. And anytime someone wants to ask questions about the Vizio TV, it's going to know to use this tool to answer that question. A couple things to point out with this is that this is the function that's going to get called. So anytime the LangChain wants to use this tool, that's the function that's going to get called. And then what you also do is you give it some context of when to use it. So the description is very important, because I hear them saying, look, anytime you see questions that look like it's related to the Vizio TV, instead of using Wikipedia or SERP API, those tools, I want you to use this tool instead. All right, so now I've got 4 tools that I can now use. So here at this point, I now have not only my data that I can query, but I can query that data alongside other tools. And then what I can do is I can ask the questions and then let the engine decide what tool it needs to use. All right, and that's how we pull this together, is we take that tool, the collection of tools, and we initialize an agent out of it. And the agent takes in the large language model and takes in some other things, like, for example, conversational memory, so it'll know, and some of these other settings that you can use to fine tune how the model is going to work, right? How is the LangChain model going to be able to figure things out, right? One caveat with these models and these agents is that it's going to try to figure it out. It's going to try to figure out what tools are going to answer the question based on what it needs. And it may take multiple iterations, right? So it's not just one thing. I might ask it a question and it might have to go to Wikipedia first and then go make a math call and then go look at the Visio TV guide manual, right? So it's going to figure out what the sequence needs to be in order to answer the question. Okay, so you'll kind of see some of that as we go through this. But once I have the agent, all right, and I have all the tools kind of linked together, now I can ask it the questions, and based on what question I'm asking it, it's going to pick the tool that makes the most sense. So for example, here I'm asking who is the current president of the United States, and sure enough, it went through and said, based on that question, I'm going to use the search tool. That happened to be one of the 4 tools that we included. So now it knew to go look the search up using the search tool and answer the question that way. However, if I ask it another question, for example, who was the 33rd president of the United States, you'll notice at this time, and you're seeing all this data because I have verbose turned on. Otherwise, you wouldn't see all this. But I'm just showing you the thought process. What you see here is the engine deciding how to answer that question, okay? And so if it's multiple steps, you'll see the observation of what it thinks it needs to do to answer the question. So it's saying, okay, well, if I want to answer this question, I need to go out to Wikipedia, and then I need to get that answer and input that value and get back an answer. And sure enough, it got back that question. What's also nice is since it has memory, if I ask it another question, it knows it already had the other one there. So it was able to figure out that I was talking about Harry S. Truman, and it was able to figure out when he was born based on that context. Okay, so you have conversational memory that's being maintained as you make these requests. Now, if I ask it a question about the Visio TV, you'll notice that the action that it chose was the Visio TV knowledge base. So now it says, oh, okay, you're talking about Visio, then that tool I'm going to choose is going to be the Visio TV manual, PDF, that we have earlier. So you can add as many of these tools as you want, and the more tools you have, there's kind of a trade-off because you don't want to add too many because you don't want to get confused about which tool to use. You want to try to give a little bit of help as much as possible so that you're getting the correct answers out of your response, or getting your correct response from the questions you're asking. So there it is. It used a knowledge base, and then it went through and came up with the answers for things that would help me with my Visio remote control. You can also combine these. So for example, if I said, what is the current temperature in Washington, D.C., and what is that to the power of 3, you'll notice that it ran a search to figure out the current temperature in Washington, D.C., and it got back 71. It got back 71 degrees, and then it said, okay, I need to go further. And then it did a calculator. It used the calculator to do 71 to the power of 3. So it's combining tools, and it's figuring out the order in which things have to happen in order for you to get back your response. So I know that's a lot. I did want to just kind of quickly go through that so you can kind of have a sense of how this works. Again, the next step, if you wanted to then take this a step further, would be to put this into some type of front end. But you can kind of see that the actual code itself is pretty straightforward. There's not much to it. A lot of the details that we went through is really more of the thought process and the data that comes back and forth between the various engines. Okay. Hope you enjoyed it, and if you did, please do me a favor. Please like and subscribe. And if you have comments or questions, or if you have ideas of other types of videos that you want to see me put together, put those in the chat. I'll definitely would love to hear from you on that. And with that, we will wrap it up. Have a great rest of your day. Take care.